Hi, everyone. Thank you for joining us for today's webinar, Applying the Pillars of Object-Oriented Programming to Test Automation with the brilliant and thought-provoking Angie Jones. It is obvious that Angie needs no introduction, but I'll give a short one anyway. As Senior Developer Advocate at ApplyTools, Angie Jones specializes in test automation strategies and techniques. She's a world-renowned speaker and thought leader, a pillar of the test automation community, and you can often find her speaking and teaching at software conferences all over the world, as well as writing tutorials and blog posts on angiejones.tech. As a master innovator, Angie has over 25 patented inventions in the US and China under her name. With all of that, I have no idea how she manages to have any free time, but in her spare time, Angie volunteers with Black Girls Code to teach coding workshops to young girls in an effort to attract more women and minorities to tech. So I think I'll let Angie do the talking from now on. So Angie, the stage is yours.
Thank you, Adi. What a great intro. You have to send me that so I can put it in my own bio. That was amazing. Okay, hi everyone. Today we're going to be talking about applying the pillars of object-oriented programming to test automation. So I used to teach programming classes at the collegiate level. So I know how students learn these concepts of like object-oriented programming, and they seem to understand this in theory, and they can even apply it a little bit to the, basic assignments within the classroom. But where I see a gap is where people enter the industry, they lose focus on how to apply those same concepts that they learned in academia to the software that they're writing. And this is true of developers, of automation engineers. And so what I want to do today is I want to go over the 4 pillars of object-oriented programming. I'm going to give a refresher or an introduction to what are these pillars, and I'm going to specifically show how they can be applied to test automation. Okay, so the 4 pillars that we're going to discuss today are encapsulation, inheritance, polymorphism, and abstraction. Now, I'll go over each one of these sections one by one. When I finish a section, I'll go ahead and take questions for that section so that everything is in context, okay? So if at any point while I'm going over the slides, if you have a question about what I'm saying, go ahead and type your question in right then, and then I'll pause when I'm done with that section and do a little Q&A section after each, okay? All right, cool. So let's get started. We're going to jump in with encapsulation. So what is encapsulation? It's essentially this concept that allows you to protect your data that's inside of a given class, right? So let's look at a really basic example. This is a class called person. It has 3 data fields: the name, the age, and a gender, right? As is, this class has not protected its data, meaning that any external class can access any of this data, right? So, and to encapsulate this, it's fairly simple. You make the fields private or protected so that no external force that you don't want to have it can access it. And then you provide public methods to be able to get to that data. So here we made the name, the age, the gender. We made all of that private. And we have getter and setter methods here that allow for anyone to get the name or set the name, right? A lot of times my students will say, well, this doesn't really seem to make sense. It seems pretty straightforward. Seems like a lot of work. Why do we have to do this, right? So in these basic examples that we teach in academia, it's not really apparent why this makes sense. But in larger applications, you have your data, but the methods that you provide for them may do more than just a little get or a little set, right? Even the get or set might be more involved. Like maybe you need to not only set the field, but you also need to do some back end stuff as well. So it's a matter of being in control of how your data is accessed. You don't want people to just access it any old way, right? In test automation, fortunately, we already have a design pattern that encourages encapsulation, and that's the page object model design pattern, right? So let's look at this Applitools page, and this is within Twitter. So this is Twitter's Applitools page. And let's say we wanted to automate against this page. Well, if we were using the page object model design pattern, what that pattern says is that for every page in the application, there should be a corresponding class within your automation framework to interact with that page, right? So in our framework, we would have a class for profile page, and we could put all of the data as the elements that are within this page, and then we would have corresponding methods to work with that data. Now, using that pattern to encapsulate that, of course, you would want to make your fields private and your data public. I mean, your methods public, your data private, your methods public. So there's a lot going on this page. So we'll just focus on one little small area so that we can see this in action. The highlighted area is the bio. Okay. So if I were to make a class, this is called the profile page. Notice my data is my driver, and then this bio element, this locator. So both of those I've made private because I'm protecting my data. And then I have a get bio method that essentially give access to this bio. Now notice this is not as simple as the person class where it's simply returning the bio object. It actually needs to be an action that occurs here. It needs to take the driver, go and search for this element on that page, and then provide the text back. So you see how this can get a little bit more involved. Also, encapsulation helps to prevent other code smells that could occur later on. For example, in test automation, we encourage you to have your tests separated from your framework or things that are driving the browser and that sort of thing. So this page would be like an example of something that goes in the framework section. Well, you don't want to expose things like this bio web element, this buy locator and all of that to your test, because if you expose it, then you are essentially allowing for a test class to have access to that and bring that type of level of information down to the test layer, which is discouraged. It'll be a code smell if they did. So one way to avoid all of that is to encapsulate your data. Okay. So that's encapsulation in a nutshell. That's pretty simple. Fortunately, we have the page object model. So this allows us to understand encapsulation a little bit more. I'm going to stop now and see if we have any questions so far around encapsulation. Adi, do you see any questions on your end?
I think so. Yeah, we got two of them.
Okay.
Do you
Yeah, I
want me to
can't
read
see
them out to
questions,
you?
so I'll just default to you.
Okay, no problem. So the first one, we can still access the variables through the method which is public. Why not that is private?
Say it one more time.
So we can still access the variables through the method which is public. Why not is that private?
Right. So again, when you look at the basic case, I get what you're saying. Like all this does, for example, the get name, all this does is return the name, or the set name, all that does is set the name. But these are not like real life cases. Most times they'll be more involved. For example, here with the get bio doesn't just return that private bio variable. It uses it in some context to do something more, right? And so just exposing that to the test doesn't give them what it is that they're actually after. And so you're forcing them to get your data and then do something else with the data that could be right, could be wrong, right? So instead of that, you protect the data and provide the functionality that you know is correct for them instead. So yeah, in the get set, where it's doing nothing more than just setting the fields, it's not really apparent why that makes sense. But when you look at it more in this case or broader cases, for example, if you needed to set, you call some set method. Not only does it set the field, it also needs to do some database transaction or something behind the scenes. There could be a lot more that goes into it, and you can get yourself out of the state that you need to be in if you're just directly accessing the data without the corresponding functionality that should be exercised. I hope that makes sense.
Next question. Angie, do you want the next question?
Yeah. Next
Okay.
question.
Sure. So wouldn't Page Factory and WebDriver class be better for encapsulation?
So Page Factory, it might be better for encapsulation. However, Simon Stewart, who is the lead maintainer on the Selenium project, has publicly stated that he wants us to stop using Page Factory. So this was something that he created and he regrets it for various design reasons. So if the guy who made it says don't use it, then I don't use it. So I stay away from Page Factory.
Okay, by the way, you tell me until I'm going to keep on with the questions until you tell me when to stop, okay?
All right.
Until you want to move to the next topic. So next question. When we do have many common components in diff page, how will you design page objects?
Okay, yeah. So I think we'll get in that when we go to the next section. So let's save that question. If I don't answer it after that, then bring it back up for me, please.
Great. So next question. Would using something like testing or unit tests that uses classes already count as encapsulation?
Using something like what?
Like unit testing.
I'm not sure I get the correlation between the two. If you want to clarify the question, go ahead and type your clarification. But Adi, let's go to the next one.
Sure. Is it anti-pattern to encapsulate entire actions that one would encounter on a utility layer? For instance, the action of clicking the login button.
Right. So if you wanted to do something like that, like you have a utility that will click some things, you can make these things public. Sometimes people, like say for a login, you might have a login method that takes a username, takes a password, and in that method, it'll set those fields and click the button, right? And in that case, sometimes people have those three actions: setting the username, setting the password, and clicking the button, separated out into their own methods. And they might make those methods private and just leave the utility function. I make all of the methods, those types of methods, public. So it's more about protecting the data. Encapsulation is more about protecting the data and not necessarily the actions, right? And so those actions I like to leave public because I have the utility one that you can call with the username and password, and it does the happy case. But there you might want to build a test case that doesn't follow the happy path. For example, you might have a test case that sets the username, doesn't set the password field, and then clicks on the button. So having all of that just public and allowing people to build as they want to build makes your framework more flexible. As long as the data itself is encapsulated, then you're okay. All right, one more question, Nadine.
One more question. Okay, languages like Python don't have an option to make page object members private. Does it still qualify?
So I'm not an expert in Python, but I believe like there's some languages that essentially keeps its data private by default. So in Java, if you don't specify an access modifier, then by default it's public. In some other languages, that's not the case. Like you can't access data outside of the class by default. So I'm not sure if Python is one of those languages. I'm not well versed enough in it. All right. Okay. So I'm going to move on to the next section. Continue your questions. We'll still go over those. We'll look at some at the end as well if we have time. Okay. So the next section is on inheritance. And inheritance is essentially a way for one class to share its behavior and possibly its data with other classes, other similar classes, right? In my opinion, inheritance is extremely powerful. It's probably the most powerful concept in object-oriented programming. I believe that it's underutilized in test automation. A lot of that has to do with cautionary tales where people will say, oh, you don't need to do inheritance, it's too complex, or you might get yourself in trouble. Well, that's why you need to do it properly. So hopefully I can share some examples on good cases and ways that you can use inheritance. So let's go back to our person class. And if we look at this class, it's fine. It has a name, an age, a gender, and it represents pretty much any person, right? So this is a nice common class. But we have cases where we have more specific, like maybe a more specific type of person where this is still true, but there's additional information that that person needs. For example, let's look at an employee, where an employee is also a person. So employee wants everything that a person has, the name, the age, the gender, but it also has things that are unique to it, such as the employee ID, start date, salary. So you don't want to get into a situation where you have to basically copy all of this stuff that already exists in one class, put it in this class, and then add additional detail here. Instead, what you can do is use inheritance. And in Java, the keyword for inheritance is extend. So on that first line where it says employee extends person, this is saying that an employee is going to inherit the public or protected things from person. Okay, so in this, everything that is here is specific to an employee, but employee also gets all of those public methods for free. Let me show you this example. So here is where I'm creating a new object that's an employee. And then I can use that employee object to call set name. Now notice set name, that method does not exist in this employee class, but because it inherited from person, set name is there, I can use it in this context. So this is really helpful when looking at test automation. If we look again at Twitter, this is my home timeline. And if we look at the very top, there's a header. So a lot of our applications have these headers that are present across the app. So here is another page in the application. This is my profile page now, but that header is still there, right? So the home, the moments, the notification, all of this stuff is still present. So the way that I would go about doing this is instead of like trying to repeat that header across every single page that I create, every single class that I create, I want to put it in some common place that I can access it. Now, a lot of people will say, well, I'll make a header class. This is probably the most common way that I see this done. And doing a header class is fine. I'm not saying there's anything wrong with that, but there's an advantage to using inheritance over just putting it in a header class. If you put it in a header class, then no matter like where you are in the application, you then have to make a call to the header class to be able to do that. So either instantiating it, or if it has static methods, to a header class dot whatever, go to this blah 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 blah, right? So there's an additional step there. There's also this cost of figuring out where it is. So I would need to see, is this header class, is it in my pages package? Well, it's not really a page, so maybe it's not there. Is there a separate thing for components? Maybe I need to go to that package. And so there's this cost of looking for the information, right? My proposal, the way I would do this, I would make a page class. And for all of the things that are common across all of the pages in the application, that can live right here in this class. So here you see that I have my elements for these navigational links, and then I have methods so that you can go to these things, right? And then what I would do from here is every subsequent class, page class that I make, can then extend or inherit from that page class. So if I made a notifications page, I can inherit from page. So I get all of that stuff for free. And then I can just add the stuff in the notifications page that's specific to the notifications page. Look at this test at the bottom. So this is test navigate. We start off by just instantiating the um, generic page, the common page, right? Doesn't matter where we are in the app, that'll be fine because all of them inherit from that. Then I make a notifications page by saying, okay, page, go to the notifications section. That gives me a notifications page object back. And then on notifications page, I can say, go to moments. Now, notice in notifications page up top, there is no method in there called go to moments. But because it's in the page class that I inherited from, I now get that for free. So I've now shaved off all of that responsibility of trying to figure out where stuff lives and where it is, because technically from any page in the application, I really can go to moments in the real application. So my code should mimic that same type of behavior. So on notifications page, it should be no problem for me to say I want to go to moments. I shouldn't have to instantiate yet another class, which is the header object class, and then try to go to moments. Okay. Now that's a basic example. Let's look at a little bit more inheritance in automation. It's going to go a little bit deeper. So let's look at our profile page that we talked about. And now profile page extends page, and we have that little bio element, and then we also have where we can get the bio, right? So this profile page, does it correspond to this profile page, which is Applitools profile page, someone other than me? Or does it correspond to this profile page, which is my profile page? Well, if we look at both of these, they both have a bio. So this is fine for now, except when we want to start adding additional information in this profile page. For example, if I look at these two profile pages, there are some variances between them. On someone else's profile page, in the left column, you see that tweet to button, and you also see a message button that doesn't exist on my own profile page. And then on my own profile page in the right column, you'll see the edit profile button. Well, that doesn't exist on someone else's profile page for me, right? So these are both technically profile pages, but there's different actions that are specific and unique to each of these cases, which means they're not quite exactly the same. However, they do have quite a bit in common. So the way that I would solve this is everything that's common, I would put that in the profile page. So that bio piece, that's perfect in the profile page. However, I would also make my profile page, which means me, the user. If I go to my own profile page, I can inherit from profile page. So I get everything that's common to all profile pages, but then I also can put what's specific to my profile page, such as this edit profile button here, right? And then same thing if I was using someone else's profile page. So if I was doing another user, you can call this whatever. So I called it user profile page. You can call it whatever to indicate that it's somebody else's profile page, right? And then in there, this also inherits from profile page. And so it gets all of the commonality that exists across any profile page, but then it also can specify the stuff that is unique to someone else's profile page, right? So you might think, seems a bit complex. Can't we just put everything in profile page, which is what most people do? The problem with that, if you put everything in the profile page, you get into cases within your test where you now have access to methods or actions that don't make sense in that context, right? So you are on your profile page within a certain test, and now you click dot on that object to see what options are available to you. And one of the options is saying to click tweet to user button. Well, that action does not exist when you're on your own profile page. So in those cases, people start adding comments and stuff saying, oh, this should only be used if you're on somebody else's comment. Now I'm in the test and I have to start reading the comments to determine if I can use this method or not. That's not good, right? You can make this much more cleaner by just separating it out and using inheritance, right? So that's inheritance in a nutshell. What questions do you all have so far?
Okay, first one. How can one use inheritance to achieve page fragments? This is a page that inherits from more than one other smaller page class. Say the home page class includes the header object plus the footer object plus the sidebar object.
Mm-hmm. Right. So that would be, let's see, the first example I talked about. So in this page, you put everything that's common to like all pages or your home page, for example. So everything that's common there. And then in your subsequent pages, you would just extend from that. So those things those newer pages, you would extend from that page and then add the functionality there. Now, if you're talking about components, then I wouldn't use components with inheritance like this. For example, let's say we had, let's look and see if I can see a page here. Right. Let's say we had tweets, for example, this tweets section as a component, and we wanted to make a separate page there because there was just so much going on with the elements and the methods, and it got really long, and we just wanted to separate it out into its own component, right? So you can separate this out into its own class, and that becomes a component class. What you don't want to do is then introduce inheritance and say, oh, tweets page or tweets components extends from page, because that's not true. That's no inheritance there, right? This tweets is its own separate component. So instead of trying to force inheritance in that case, remember when I said sometimes you can misuse this and this is where you get into trouble? That would be a misuse. Instead of doing that, I was simply in the let's find this class in the profile page class. Yeah. So in the profile page class or wherever, if I wanted to do tweets, I would separate the tweets out into its own component, but then I would also have a method in this class that said get tweets or something, or get tweets component, something that gives me a handle to it so that I don't have to go searching through the entire framework to figure out where things are, because tweets does exist on the profile page, but I'm extracting that logic out and putting it into a logical component, which is another class, but still provide the access to that component from whichever class you're going to take it out of. I hope that made sense. Any other questions, Adi?
Yeah, we have quite a lot of them. So again, I'm going to keep asking and you tell me when to stop.
Okay.
So we have a lot, really a lot of questions here about inheritance versus composition. So I'm just going to take the one that I think that's the most comprehensive one. So where do we draw the line between using inheritance versus composition? It's often easy to use inheritance, but can lead to a lot of design issues down the road. Any
Yeah.
ideas where to use what would be great from page objects point of view?
Yeah, I think I just answered that one with the other one, Adi, with showing that example of where you can take out these components. You don't want to introduce inheritance there when you take out the components. Instead, just provide a method that'll get your test or your caller, get them to what it is that they want. So you can separate it out. Don't use inheritance in that case. Instead, just provide a method where in my test I can say, give me the tweets component, and then I can have all my actions I need off of that tweets component.
Okay. Next one. Would you recommend extending this approach to multiple different platforms running the same app, more or less? Would it be better to isolate the same screen to different classes, no inheritance, on account of the differences in driver and the way the UI automation works between them?
If you find yourself in a situation where there's just so much difference between the stuff that inheritance doesn't make sense, don't use inheritance, right? So I see a lot of thought leaders who will try to steer people away from even using inheritance. And I think this is why, because it can be misused in a lot of ways. So you have to really understand where it makes sense and apply it in cases where it makes sense, right? So in the cases that we've looked at, we saw where, okay, we have a profile page, we have a bunch of stuff that's common, we have two variations of this profile page. So that makes sense in that case to use inheritance, where we can say, put the common stuff here in one spot, make two classes for the two different types of profile pages we have, and just inherit the common stuff and implement your own unique stuff. That's basically the guideline. That's what makes sense. We saw that also with the page class. So all of the pages have this common navigational function. Just dump it in that common place, and then anybody else who is also a page that also has this common functionality, instead of repeating that information, go ahead and inherit it. So don't try to force it. If it looks like it's going to be too complex, it doesn't really make sense, don't do it, right? You don't want to get yourself in further trouble. But when you start noticing patterns where you would have to like copy paste stuff from multiple classes and have them redundant in multiple places, or everything is lumped into one class and there's different states involved, and you can only use some of this functionality in this class within this state, and then it's not relevant in some other state, then you start saying, okay, I got myself in a pickle here, and inheritance might be able to help you out of that. All right, Z, let me do one more.
One more. Okay. I hope I picked the right one. When do we stop making classes and make a member? Like bio could have a class of its own and be inherited to profile page, or it could exist as a member. What is a good practice?
So if we're using the page object model design pattern, which I use, then this by is definitely that pattern specifies that your elements are a part of your class, and your actions on those elements are the methods of that class. So I would definitely just keep the by there. I don't really see a use case off the top of my head where you would take a single by and put it in its own class, and definitely no inheritance involved with that. I have seen some shops that'll put all of their buys in like kind of one class and call this like their object factory, if you will, or object map, and put everything there. And that's worked okay as well. I really like it all within the page, so I don't have to go looking for things. I know if I'm on the user profile page, I know that there's this button here. I should be able to go to that class within my framework and find that button and be able to do all actions that I need to do with that button. All right, so let's move on to polymorphism. So polymorphism is interesting concept. It's the ability for an object to take on many forms. So not just what it's defined as, but it can take on the form of other things as well. So let's look at a classic example of an animal. So we have a class called animal. It has a method, makes sound, right? And this just prints out a blank for now. Then we have a dog, which is a type of animal, similar to like our employee is a type of person. So we have a dog, which is a type of animal. So it gets the make sound method for 3, but that makes sound in animal prints a blank. Well, in dog, I don't want to print a blank. I want to essentially override what I got, what I inherited, right? Give me what you have, but I'm going to override it by declaring it again. So defining it again. So in dog, although I had make sound for 3, I inherited it. I redefined what make sound means and then changed the implementation details to say wolf. And then I also added an additional functionality, which is fetch here, because that's specific for a dog. Now let's say we have the cat class, also inherits from animal. So the cat also wants to make its unique sound, so it overrides the make sound method of animal, changes the implementation to say meow, and then adds its own specific method, which is scratch. Okay, now let's look at this in action. Let's say we have a zoo class and we have a dog object. We'll call him Rocky, and we say Rocky dot fetch, and we say Rocky dot make sound, and then we call this method within this class called feed, and we pass it Rocky. Now remember, Rocky is a dog, but at the bottom here we see this feed method, which takes an animal, not a dog. However, because the dog inherited from the animal, it can also take the shape of an animal. So this is perfectly legal to pass in dog there, even though it says it takes animal object. Okay. And if we ran this, it would print out fetch is fun, wolf, and here's your dog food. Now, if we look inside of that feed method, that's what's printing out that last line, we can use this operator, which is instance of. So I'm taking an animal, but I can then kind of drill down to determine, okay, what is its base origin. So here I say if animal is an instance of dog, meaning it's a dog class, then go ahead and print out the here's your dog food. And if it's an instance of cat, print out here's your cat food. Okay. So back up to the main method in zoo. If we look at the next part of that, we have this time an animal object called Sasha, but we instantiate Sasha as a dog, right? So that's really like kind of funky. Like, okay, we can declare its type as one time, but instantiate it as something else. Wow. Okay, so with Sasha, what does Sasha have access to? Well, make sound, and then we'll call feed. What will come out in this point? Well, in this point, we have make sound, which would still be wolf, right? Now, notice in the animal class on the left, make sounds prints out blank. And Sasha is technically an animal, but we instantiated Sasha as a dog, which means that it'll get the overwritten method from the dog class, thus printing out wolf. And then we call into the feed, passing in Sasha. And even though it's of type animal, it recognizes that it's also an instance of dog and then prints out the dog food. And then, really funky here, we can change Sasha from a dog to a cat now. Really polymorphism at its finest. So Sasha, we now take that same Sasha object and we instantiate it as a cat. And then we call make sound and feed. Now it's a meow. And here is your cat food. Okay. So this is polymorphism. And we can use it in test automation. If we look at the profile page that we had earlier, we instantiate we had two classes that inherited from profile page, my profile page and user profile page. Now they both inherit from profile page, but they're not related to each other at all. Okay. Now, if we made a method somewhere in our page class that says go to profile and we pass in a username, what should be the return type? Remember, we have my profile page and we have user profile page. At this point, we don't know what username they're going to pass in. So we don't know if it should be the my profile page or user profile page that should be returned. So how do you handle such a case? Well, what I would do is my return type would be profile page. And then inside of this method, you can get a little bit more creative where you say, okay, if the username is equal to the user that's logged in, maybe you have some functionality to get who's logged in. If those usernames match, then we know that they are on their own profile page. And so you can return new profile page, even though you've declared in your signature that the return type is profile page. How can you do this? Because my profile page is an instance of profile page, so it can take on that shape. And then if it's not the logged in user, you can just go ahead and return user profile page because it's someone else's page. So let's look at a test with this in action. I have, I create the page object. I then say go to profile and I pass in my handle, which is TechGirl1908, right? And then I say, okay, this is my expected bio. And then I do an assertion here on that bio. Now notice with this last line, I say my profile page dot get bio. And I've when I went to the profile, I went ahead and put the type as profile page. Now that's what's going to be returned back. So this is all fair, everything is fine. Get bio exists in profile page, cool. But we can also do something like this where I want to test the tweet to user from their profile. So I have a page. From that page, I say go to profile and I put in the Applitools eyes handle. Now in this case, I'm on someone else's page. So what's going to be returned is the profile page, but it's going to be an instance of this user profile page. So I can essentially do a cast here to say, go ahead and make this of type user profile page because I want to be able to access the methods that exist inside of user profile page, not just profile page. And so we see on our assertion there, we can then say is click tweet to user button enable, which would only be available in the user profile page. Now you got to be careful with this, with the casting. This is generally frowned upon, only because you can goof this up pretty easily, right? If you try to cast this to, say, for example, my profile page, then this will blow up with an exception, basically saying that that's not legal to do, right? So you really have to know what you're doing. Because I know for a fact that I'm not logged in as Applitools eyes, then this test will be fine. But if I were to log in as Applitools eyes by mistake, then this would blow up. So you just got to be a little bit careful. But this is just an example of how you might go about using polymorphism within your automation. All right. What questions do we have around polymorphism?
Well, right now, not a lot. I see the only one that I have now is a question by Jill asking, does that mean that there is no longer a dog named Sasha?
Let's go to Sasha. So when we made Sasha a cat, you're correct. There's no longer a dog named Sasha. We took Sasha, who was literally a dog, and we made Sasha into a cat. So we totally changed that object. So correct. All right, I'm going to move on then, since there's no
No,
questions.
we have one more. No, we have one more, if that's okay.
Okay, yeah.
Great. What is your view on using singleton method for every page class in your design rather than going to this complexity?
Using what?
Singleton method.
Oh, yeah. So I don't really have a preference. I don't use I use polymorphism very sparingly, because like you said, it's so complex. So while it might make sense, sometimes you have to trade in complexity for um things that are easier to understand and stuff and maintain, right? So if I'm building a framework where it's not just me, there's other people involved. We want our testers to contribute. We have more junior automation engineers and things like that. This kind of stuff can get complex, and then it's like, okay, I don't know how to work with this stuff, right? So in the cases like those, you might seek out another option, like you've mentioned, to be able to do it in a different way. And so you're trading that in. So this is just one example how you might be able to do this. I use this very sparingly because I don't want to do all of the casting and all of this stuff like this. Only where it makes sense would I introduce something like this. So yeah, don't go off and say Angie told us we should all put polymorphism in our frameworks. I did not say that. I'm only showing you how you might be able to apply this where it makes sense. Okay. All right.
We have one more question. Is that okay? Can we take
Yeah.
one more?
Yeah. One
How,
more.
okay, so how to apply polymorphism on a big team?
On a big team. So the team size doesn't matter. It's more of the framework, right? So if you had, let's say, in this case, um, all you have is like these three classes where two of them have a relationship with profile page. You could then, if you had more than just my profile page and user profile page, and you had like 4 or 5 of these different types of profile pages, then that can get pretty big and complex, and you still follow this same pattern if you wanted to go down this road of using polymorphism in that case. You just got to be very careful with like the casting pieces of it, or the checking. So in our case, there was an easy way to be able to check um, which should be returned back with this with this my profile page versus user profile page. And some cases it might not be easy to determine what should be returned back, so you can still put the generic thing back, but when you return profile page, whoever calls you and gets profile page back, at that moment they only have access to the stuff that exists in profile page. They don't have access to the my profile page specific methods unless they do that cast and get that type. So you'll find yourself having to do the cast if you do this a lot, which is typically frowned upon and gets kind of complex. So if you start seeing where you have a lot of these classes, you might want to take a step back and refactor and think of a cleaner, more simpler approach to doing that. All right, let me move on. So this is the final section, and it's fairly quick. So this is abstraction. Let me just say that I pretty much rarely use abstraction in my test automation. I just don't find the need to do so. But I'll still give you an example in case you have a situation where it makes sense for you, right? So with abstraction, this is essentially providing like a template or a blueprint of how something, or not how, but things that should exist and be implemented as you will, right? So let's look at this interface, which is a product. And this interface defines methods. So an interface doesn't typically provide implementation details. Instead, it's just giving you the blueprint, the template. It's saying if you have any type of product, then your product should have these methods in it. You should be able to get and set a price, get and set a name, get and set a color, right? For any product. I don't know how you're going to do that. I don't care how you're going to do that, but these are the things that should exist in your class, right? So let's say you then had a book class that implements product. Now, if you have an interface, you're implementing the interface. It's no longer inheritance because there's not really anything to inherit. You're essentially going to add the details of those methods. So I have a book that implements product, which means I get, um, that means I'm going to have to implement these 6 methods. And so you go about that with implementing those methods there. I don't have all of them in there because I ran out of space. But you can do that, and then you can also add your own fields in there as well, right? And so that would be a class that implement product. Now, if your class didn't implement everything in there, you would need to then make it abstract because it didn't implement everything. And so abstract class is similar to an interface, except that it has some implementation details and some things that are just abstract templates. Okay. So in automation, here's an example that you can, would use something like an abstract class for. Let's say, for example, you had a list widget. This is just a generic abstract concept of a list widget within your application. You don't know what kind of list it is. It doesn't really matter. But you're saying, okay, if you had some list of a list widget, you might have uh, a method called get items, and that should return a list of widget type, right? And so that part is abstract, meaning I'm not going to provide the details to do this. Depending on what type of list widget you are, that could vary. And then you have another method that has some implementation details, get number of items. And there you can say, okay, I don't care how you got the list, but I know how to specify the number of items in that list. It doesn't matter. It's a list. I can just do a dot size. So I'll go ahead and implement that much, right? And so if we look back at our Twitter example, we can see here an implementation of that where it says, I'm going to make a tweet list. So that'll be my widget. It'll be a tweet list. It's going to inherit from that abstract class, which is list widget. If you inherit from an abstract class, then you need to go ahead and implement its abstract methods. So it has the get items method here with the implementation details of how it would go about getting the items for a tweet list, right? So this is specific to the tweet list. Other things that might implement or inherit from list widget, then they might have another way to go about getting them, right? So this is specific to this one. So this is just an example. Like I said, I rarely find a case to use um, abstraction within my test automation framework. So I don't really have interfaces or abstract classes very often. I have been on projects where it was needed, but in most cases, this is just not really needed, not necessary. All right. So that is what I have on object-oriented programming. You need to show your test code some love, just as you would if you were a developer. So knowing like these different concepts and being able to use them can help make your framework more flexible and more easy to use for your testers or whoever is implementing your tests. All right. So Adi, do we have time for questions?
Yeah, I think so. Not a lot, but we do have some time.
Okay.
So the first one is there an open source test automation framework on GitHub or somewhere else which implements these object-oriented programming concepts and can be analyzed for reference?
I don't have it there. I probably should make it. Like I just kind of coded up this stuff in snippets as examples. There's like typos in them and everything. But I can probably whip something up that probably would be helpful for people. So yeah, I'll put that on my list of things to do.
Great. Next question. Is it suggested or recommended to use these relationships for continuous testing where we do not have a stable database and interface? For example, testing a list of clients do not have the same client on every refresh or on every deployment.
Right. So that's a test data problem, which is like separate from using object-oriented concepts. So these object-oriented concepts won't help or hurt you in those types of situations. It's more get into your test data strategy and figuring out how to better do that. Paul Merrill, Merrill, he has written and done a lot on test data stuff. So you can probably like Google him and be able to find some information on that.
By the way, I just wanted to say before the next question, I see all your thank you notes for Angie, and I promise that I will send them to her once the session is over. So you can bet that she's going to see them and get them. Okay, next question about encapsulation. If you make date private, do we have to write every function to operate on that data on that page class? This can result in creating hundreds of functions on that specific class. Is this the intended design?
So it sounds like you have a lot of different actions that can occur on a piece of data, right? If you don't encapsulate that, you might think, well, I'm not going to encapsulate it. I'll allow people to just get the data and have them implement it how they want in their different classes, right? Um, the problem with that is then you start leaving like too much of the burden on other people, your callers, the people who are calling into your class. So it's better to essentially put all of the functionality that's related to that piece of data in the same class. That way, everyone knows what's there, what's available. You don't find different classes repeating the same methods because they didn't know that it even existed somewhere else. So it really still does make sense to go ahead and put it there, even if it's a lot of methods for that data. It'll save you pain in the long run.
Great. So actually, right now we are out of time for today. So I wanted to thank everyone to join us for this live session. And of course, to thank our brilliant speaker, Angie Jones. I saw all your questions about the recording. And yes, we will email you the recording. You will get it by Monday.
All right. Thank you all so much for coming. This was fun. I love when I get to do really hands-on technical talk. So thank you so much for allowing me to do so and coming and joining in. Again, here's my contact information. If you have any questions that you're just dying to get the answer to and we didn't get around to it, feel free to reach out to me at angiejones.tech. So that's my blog post. I also have a subscription piece there so you can sign up. So whenever I produce new content, I'll let you know about it. And then also my DMs are open at TechGirl1908. So you can DM me, follow me if you want. I pretty much talk about cool automation stuff. Otherwise, I'll see you all around. Thank you.